This is optimizing Clojurescript apps for speed. I'm Alan. I'm a Rohner on Twitter if you feel like following me. Founder of a startup called Rasterize. We do website performance monitoring, and previously I was founder and CTO of CircleCI. I've been using Clojure since forever, pre 1.0. So the talk is not about optimizing runtime performance of Clojurescript, and it's not about compiler settings or any of that fun stuff. It's almost entirely about page speed, page size, and network speed. So, we're using Clojurescript and Ohm or Reagent or one of those, reframe. And single page apps are great. We all like React. We all like the fun things you can do with it. It makes it easier to build nice UIs. Really Ajax heavy stuff, really API heavy stuff gets a lot nicer. It's not all free though. They're slow. Network size, you have all this JavaScript and then you serve it to, your browser or people on the other side of the world. It has effects. So this is proof. This is Rasterize loaded yesterday on the conference Wi-Fi. It's like, oh, it's only 200K. Well, it took 3 seconds to download 200 kilobytes. We're in a first world country. We have Wi-Fi's, and it's still slow. 1 eternity later. So there's this kind of this presumption. Everyone has good internet all of the time. Like in Derek's talk yesterday about the state of the mobile web and the 7 meg blog post that's 10,000 words. In 7 megs you could fill books with that. Everyone has good internet all the time. Well, not everyone. When you do have internet, it's not always good. You're at a conference, you're on a plane, you're on mobile, you're in San Francisco. And of course, you don't have it all the time. So, well, why do we care about network speed? Why do we care about download speed of single page apps? So this is a startup I'm working with. So the green lines are their page load times, and the blue line is the conversion rate for users whose page is loaded that quickly. So, there's a nice bell curve around 2 to 3 seconds, but you see there's this huge, you can't see my cursor. There's a giant slope here of conversion rate drops off dramatically as your page gets slower, to the point where slower people just don't buy. So this is a sports media startup, and they pay monthly subscriptions. So it's, the cost of not converting somebody is pretty high. You say, oh, well, the blue line and the green line look kind of similar, but let's look at the null hypothesis here. So if page load speed didn't matter, you would expect a flat line all the way across, right? But instead, you see a giant spike. So the cost of not loading your pages quickly is huge. And you say, oh, well, Alan, that's just one startup. It's anecdotal, whatever. This is the same slide from Walmart.com. So this is millions of people a year. So Walmart has this great talk. If you care about this stuff, they had a great talk a couple of years ago. If you just Google Walmart page speed slides, they talk about the process of improving the website. Median page load time went from like 10 seconds to 2 seconds. And so they have multiple charts of how this stuff improves. So this has all kinds of effects. Where did my slides? It's not working, as Stu said last night. Okay. So Google reported speed affects traffic and repeat traffic. Amazon said that for every 100 milliseconds that your page loads slower, Amazon loses 1% of revenue. So every 100 milliseconds, they had a visible effect. And then Walmart had the slide we just showed about conversion rate. You say, okay, fine, I don't care. I'm not building a commercial website with Clojurescript. Well, websites are about side effects. You have a website on the internet. Presumably, you're there to reach people. You're running a nonprofit. You have a cool technical blog. You have your open source code. At some point, you want people to pay attention to the thing that you're doing. And so, if you want them to pay attention, speed matters. They'll lose attention. Like that XKCD about the get bored and pull out your phone and then pull out a slightly smaller device. Same thing happens. Even if you don't care about conversion rate. YouTube has a similar anecdote where they worked on the page. They halved the site of the site, halved the speed of the site. A couple engineers, and they reworked everything, and then they published it, and they started looking at analytics, and the average page speed went up. And they're like, something's weird here. We have to be missing something. And so they dug through the analytics, and then they finally started grouping the page load speed and the traffic by region. And it turned out that because they have the size of the network, or because they have the page speed, users started showing up from remote countries that weren't previously users. So they had increased users in South America and Siberia because the network time went from completely unbearable to just mildly annoying. So speed is transformative. So let's go back to my single page app here, and we have this giant download time. And of course, so I'm gonna assume for the rest of the talk that you're convinced. So how do we fix this, right? So obviously, we make it faster. First part of this, I'll work through some very basic stuff, and then we'll get to the more interesting ones, but the basic ones need to be said. So first, do you really need a single page app? I'm assuming you do because you're not just following the new hotness, but you actually need React to do the things React is good at, but it's worth getting out of the way. Reduce your dependencies. So in a normal Clojure app, you can just have a 300-line project.clj and nobody cares. Your users, there's no user visible effect to adding one more dependency. In a ClojureScript app, every single user is going to see, or is going to have to download that code. So make sure you're doing something useful with it. Don't just add dependencies because it's fun. Okay. More basic stuff, the standard HTTP stuff. Compression, turn it on. I know everybody knows to do this, but you have to say it because I've seen a lot of sites like this year where people forget to gzip their gzip stuff before they put it on Amazon S3. Concatenate all your files just to reduce the number of HTTP requests. Use caching for everything. And people always say, oh, JavaScript size doesn't matter, everything is cached. Well, not really. Mobile browsers have really terrible caching. Mobile Safari has essentially none. If the app restarts and you come back to it, there's no persistent cache. Android has a small cache, IE has small cache. Firefox had 50 meg cache until a year ago, and then Chrome was amazing when it came out with essentially infinite cache. The other point about this is that caching only helps repeat visitors. So, again, you want the side effects. Reaching the new users is it's arguably more important than giving a good experience to repeat visitors, because you've already convinced the repeat visitors to show up again. You've already hooked them. So the first impression really matters. And finally, CDN. CDN all the things. We're in Clojure, so we know all about immutable stuff. So use immutable URLs, use e-tags. And then, because you're on a single page app, you can even do things like CDN the root HTML, because the HTML on your single page app is pretty boring. It's just load app.js, right? Okay, so now we've got the boring stuff out of the way. Dynamically loading ClojureScript modules. So this is somewhat adapted from a blog post I had a couple months ago. ClojureScript can generate, or Clojure and ClojureScript can generate modules. So basically, you split up your app into multiple files. For most of this, I'll be talking about inner and outer because it's just a standard, easy split, where outer is everything on your site that you don't need to be logged in for. So that's typically landing pages and pricing and the actual login page. And then inner is the actual app, where presumably you need a lot more of the ClojureScript React stuff. So modules are just standard JavaScript files with simple dependency tracking. The dependency tracking is at the runtime. Modules, at the compile time, it's just a file with JavaScript. So Google Clojure will generate these. You can specify ClojureScript namespaces and get a good split, so you can make sure you're only serving the code that you care about to the users at the appropriate time. And then at runtime, so in your actual ClojureScript files, you can choose which files to show and when. So it starts with, so this is, right here, we're looking at ClojureScript code. So this will be in the browser or whatever. So at the top, you have a map of module names to file names. And then the second block here of module info, those are dependencies. So when you tell Google Clojure, I want this module, it will say, okay, well, I need to make sure that all the other dependent modules are loaded. So you set all of this up, and then you can say in your ClojureScript routing, oh, I'm on outer, so then the outer module's loaded, and then when I click on this link, go load inner, and then presumably that loads the rest of your code, and then sets the inner modules loaded, and all those dependencies come in. So the big advantage there is you've now reduced the amount of code that you need to show to the users on the landing page, and so if they never go to the app, then you never need to download the app dependencies. There's a lot more information. I have a lot more sample code and how to do this on an old blog post of mine. So that's great. It's a big win. Outer gets 30% smaller. Okay, it's good, but it only got 30% smaller. Still 200K zipped in my case. Your results may vary. And remember, with the well, never mind, it's fine. Okay, so we still want to go faster. What do we do now? Well, let's try rendering on the server side, because at this point we've improved the HTTP stuff. We've cut out unnecessary dependencies, and then we're not serving dependencies to users who aren't going to see them. So what else can we do? Well, server-side rendering. So the goal here is we still have our app, we still have the inner and outer split, but on your homepage, you probably aren't using too much fancy React stuff. You're probably not using core async. You're probably not using all the nice things we have, just because landing pages are typically boring. So our goal here, we want to serve the app. We want the landing page to be fast, and we want code reuse here. It's easy to just say, oh, well, have your React app here and then have a static HTML over here, doing conventional hookup or whatever. But that kind of sucks because you already have your own templates. You want to reuse your code. I don't want to have to port them across. I don't want to have duplication. I don't want to blah, blah, blah. Okay, so let's do the stupidest thing that could possibly work. So let's use WebDriver Selenium. So, you have your server, and we're going to start a WebDriver instance, and that's going to run Chrome. So then when a user shows up, we will tell Chrome to make a request to our server. That's going to serve the single page app with app.js. Then the browser is going to render, our WebDriver browser is going to render it. Then you grab the HTML source, and then you serve that to the client. So this looks kind of like this. So here we have Safari is the client, and then they're connecting to our server. Then we connect to Chrome, tell Chrome to get the page, load the page, grab the HTML, send it back. So the advantage of this, it works. It can actually do something. It's easy to write. It'll take you an hour or two. Disadvantages. It's complex. It's heavyweight. Because now you have to set up Selenium. You have to install Chrome. And then in deploying in production, you have to say, okay, here's my jar, and I need Selenium, and I need Chrome installed, and you're probably running on Linux, so then you need headless X, so then you have to set up XVFB, and yeah, it's not fun. Oh, debugging this is also fun. So for example, if you have a JavaScript error on your homepage, once you do this, the JavaScript error will show up in Chrome. It won't show up in the client's browser because you didn't serve them that JavaScript. So now you have to say, oh, I'm going to grab logs from WebDriver and store those somewhere. I actually did this for a while. I don't recommend it. So let's try again. Well, okay. JDK 8 is out. We have Nashorn. Nashorn is a JavaScript engine. So let's load app.js in there and then call React's render to string. Sounds like a good plan. So it looks something like this. So this is Clojure script code. I have to start being careful about this. So it's standard OM stuff. Create an app state, create a cursor, build our component, and then call render to string on it. Yeah, you don't need that print line. Sorry, that's a bug in the slides. So the advantages of this, continuing on. It doesn't work. Nashorn is very unpolished. It took me a couple hours to get print line working. It took me a couple hours to get stack traces to produce anything useful. Core async hasn't been ported or whatever to Nashorn. So Core async will work in Node and it'll work in browsers. Nashorn is neither Node nor a browser. And then it doesn't have XML HTTP request. I'm sure it doesn't have a lot of other things that either Node or browsers have. But finally, it's just slow. So after loading, so I ran benchmarks on this, and after loading Nashorn and after evaling all the app code and getting it into a warm state, and then calling render to string, where is that? Go back to that slide. So after setting this up, just the final line there, that render to string, took a second for my simple OM app. So you have all these pain points, and then after that, it's still slow. So what can we do now? Let's try again. So we have Node. Node is another JS engine. So we'll do this render to string thing. Careful readers will notice this is the exact same code, which is nice. So advantages, it's fast. It's easy to write today. I tried this a couple months ago, and it was not fun, but I tried it again last week when I was hastily preparing for this, and everything just worked now. So the Node ClojureScript support has gotten a lot easier to use. So disadvantages. It's kind of like Selenium, but less so. So okay, deploying to production, you have your jar, you have Node.js, and now, okay, previously I could just upload my jar, run it in an Uber jar in a container, but now I need my Clojure jar and I need a Node container or something. I don't know. So it's the same kind of process as earlier, but we still have this complexity. And there's one more disadvantage. Now you're running Node in production. So let's try again. Okay, so going back to the goals, we have our own React app. We want server-side rendering. We want speed. We want to reuse our templates. Well, OM's written in ClojureScript. We have .cljc now, and generating HTML isn't that hard. So how hard can it be? If you guys aren't familiar, this is Jeremy Clarkson. He does some silly things like building aquatic pickup trucks on the show Top Gear. He's also famous for punching an employee. So how hard can it be? So I wrote a library called Foam. I ported OM to Clojure. So trust I don't need to explain the pun. So the way you use this, you port your components to .cljc, and then you just do require foam core as OM, and profit. So now this is .cljc. So this is what used to be an OM component, what used to be written in ClojureScript is now CLJC. So now we can use reader conditionals, and so we have this foam core namespace that just says as OM, and it implements all the same protocols as OM. And similarly with foam DOM. So then, here's a normal component. And theoretically, you don't need to change any of your components. They all theoretically work. Because this provides all the same functions, it provides all the same protocols. So how do we do server-side rendering with this? Well, it looks like the same code is pretty much the same code as earlier. So now this is Clojure code. Now we're creating our app state and our root cursor and building our component all in Clojure and then calling render to string on it. So we have our previous, the top example is the old JavaScript. Bottom example is the foam in Clojure. And as you can see, it's almost exactly the same.
What about React?
What about React? Sorry, what about React?
Did you port React to the JVM?
Not really. I ported render to string. So, and you get all of the OHM protocols. So you get init state, get state, set state, render, render state, all of those. And then at the bottom, actually, I think I have a slide on that. We will get to that. Okay, foam advantages. It's fast. It takes like 1 millisecond to render a page. There's no more deployment complexity. You don't have a separate program. You don't have to have a separate process. You don't have Node. You don't have WebDriver. And then actually, this surprised me. Porting to CLJC was actually surprisingly useful for my UI because once you're there, your unit tests can now be run in Clojure rather than ClojureScript. So then you don't need to spin up a browser. You don't have to deal with Node. You don't have to deal with Phantom.js. So actually, even if you don't do any of this other stuff, I would recommend playing with using more CLJC for your UI. Like if you have actually pure units in your UI that don't write to a browser, just put that in a CLJC file and then just use Clojure test. Foam disadvantages. Moving on. No, but seriously, I'm pretty proud of it. So the one disadvantage is you have to port to CLJC, which it didn't take me that much time. I moved my whole ClojureScript app, which is it's like 5K, and it took me an afternoon. And that's just the quick and dirty way where you just condition, you do the reader conditional thing and just no-op functions that have browser side effects. So that I can show you that later if you care. But basically, it's the UI code splits into the OHM iRender stuff, and then like for an AJAX call, it's just a no-op with a reader conditional around it. So this foam is still very early. I started working on this on Thursday. As Colin was talking yesterday with talk-driven development, this is very much talk-driven development. The other disadvantage right now is it's incomplete in the sense of I started reading the OHM code and there's a lot more options and things you can do in there than I realized. Right now it's only the bare minimum supported to get my app running. And of course the other thing is it's OHM only. Now you can probably copy the idea to reagent and reframe and all of those, but I haven't looked at their source code, but I assume, I assume they have their own protocols and their own functions to shadow. So you'd have to basically just copy the idea of I'm going to make a Clojure namespace that shadows all of the implementations of the normal Clojure script. Okay, so how this stuff works. So foam core just, it's just normal Clojure. It's just def protocol, def protocol iRender, def protocol init state. You get, quote, the same protocols. And the reason you get them is because right now I'm assuming you get I'm assuming everybody does require OHM core as OHM and then does OHM iRender. If you actually referred to things by their global name, if you required, or if you implemented protocols as OHM core / iRender, that would break for now. Monkey patching is possible. I'm just waiting to see if that's necessary. I'd like to avoid that. And to answer the question earlier, this doesn't implement React. It doesn't need to because you're not diffing anything on the server side. Let's see. So then, in the real OHM DOM, you have functions that return JS objects that implement React protocols, and render to string is just another React protocol. On the Clojure side, you have a function with the same name that returns a def record that implements a foam protocol called render to string. And so then when you call that, you get an HTML string that you can just serve. And we can go through that in a minute. So it doesn't need to implement React. It doesn't need to, because we're not diffing. But you still get a similar object tree. You still get. It's not important. Let's skip that. All right. So in the future, this does need more stabilization. It's still not quite ready for production. But so far, I haven't seen any obstacles for why it can't go to production. Needs more complete implementation. Like I said, it does the bare minimum right now. If there are features in Ohm that I don't use or didn't understand when I wrote the source code, I just didn't copy those. I haven't looked at what Ohm Next will do. It'll probably need to rewrite this, but that's fine because foam is actually pretty small. It's only a couple hundred lines. Merging. Obviously, it's not up to me. I'm not proposing that foam gets merged into Ohm. And you probably don't want to merge this code. But I'm pretty convinced this is a good idea. And I'm pretty convinced that something like it should go into Ohm, just because server-side rendering is such a huge speed advantage. I didn't have a slide on that. I should have gone through that. But the page load speed, once you get server-side rendering, you can drop from like 2 seconds to under a second. So I commonly see 800 millisecond page load times in production, which is a big advantage. I assume there'd be a lot of questions on this. And if there aren't, we can just go look through the source code if you feel like it. So yeah, question.
You mentioned Node was not good in production. Can you explain why?
I was just trolling. But in all honesty, though, it's if you can run in one runtime in production, that's better than having two, just because it's fewer things to update and fewer things to coordinate, and how do I get it started, and now you have to keep up to date on your patches on both Java security updates and Node security updates. So it's technically more complex, but it's more just. Sorry?
I think that your idea is actually super cool. And the question is, as I understand, if you use some ClojureScript libraries, they have to be ported to CLJS as well?
Sorry, I'll try to repeat the questions. So the question was, if you're using ClojureScript libraries, don't they have to be ported to CLJS as well? The answer is yes and no. So I'd recommend you try to get a good split. Try to separate your code into purely functional stuff and side effecting, and then use reader conditionals to no-op out anything that touches the browser. Actually, let's see if I can get. We can actually go through my actual source code because I don't care. So for example, here I have this function that loads. Oh, yeah. Okay, let's go this way. It's mostly. So this is real code. That does an HTTP call. Well, no, screw that. We're just gonna comment it out. Not comment it out, but it's a no-op on the Clojure side. So as I said, right now this is quick and dirty. This is just what was the simplest thing I could do to prove that this idea works. And so like here we have this is like login code. Setting the user. So if the user's if the code is running in JavaScript, identify the user with Mixpanel and then call Ohm update. So. Did that answer your question? Yeah, okay. Sure.
You're trying to get fast load time on your front page of your app, right?
Mm-hmm.
So I assume you call into the server-side rendering first, and you still render the app in the background
Okay. So the question was, what, if I can summarize this, what happens to the browser as you're doing the server-side rendering? And are there any races, and what does the event loop look like? So the first thing is the server response is actually very fast. So it's the time for an HTTP connect, and then this is like 1 millisecond to render. So the user won't see a lag. They'll just make a request and come back. How Ohm loads is, I don't want to punt and say it's up to you, but if you want super fast loads, then you just don't load app.js at all on like the homepage. So user shows up at your homepage, you just give them static HTML and no JavaScript. And then if they click on the login button, or if they click to the point where you have to go into the actual app, then make the event handler for that click load the rest of the JavaScript, and then you can show them a spinner or whatever you want. So on the super fast case, you're not actually loading the page at all. But if let's say a user just types in your site/login, so that forces, you can do the server-side app, but you're going to have to load the app.js anyway. So in that case, Foam will give you React IDs. So in the static HTML, you get the React IDs in the classes. So then when it does redraw, it knows what to do, and it doesn't have to. Now you'll still have to handle the race condition of, what about my click handlers? I'm gonna have to think about that. So the click handlers will load. Yeah, you'd have to think about that. Yep. Yeah.
So do you actually compute the React IDs? You wrote code for that?
Yeah, it's.
So React could take over and apply the divs.
Mm-hmm.
Wow.
So the question was, I apply React IDs. So I didn't read the React source. Let's see if this is. It's not running in production yet. So the question was, how do I handle the React IDs? I just looked at the output of running my app, and it's just a simple tree. So that the component, the root component has an ID of .0, and then the first child of that is .0.0, and then this is for everybody else, not for David. The second child of the first component is .0.1. So it's just a simple tree with the root node of 0, and then each sibling increments from 1, and then each child gets a 0 appended to it. So the algorithm is just, okay, build up my React tree, or build up my def record tree, recursively walk it, assign IDs, and then after that it's just a normal HTML class. So you just generate those. Sorry?
Are you including keys in that? Like explicit keys?
So the question is, am I including the React keys? You mean like the Ohm key function and that kind of thing? Yeah, you can easily add support for that. I will. It's not done yet, but yeah, it's nothing stopping it in production in theory. Yep.
Will remove those keys?
Sorry?
Will remove those keys, which is .0.1 in the next version, so we shouldn't really care about that.
Oh, okay. So was there a question there, or just?
No, really just.
Okay. Yeah. So it's just saying that in the future the React IDs are going away, so we don't have to mess with that.
Oh, so I hadn't heard that. So React's diffing thing will work regardless of whether the IDs in the DOM or not?
Okay.
No, I'm asking you a question.
Well, they removed them in 0.15, right? In the next version of React.
How does
So
that
work? If you go on Facebook right now, they don't have those IDs in their code, so you can see like a next version of what's going on.
So then I think your idea is great.
Thanks. I got for future record, I got the D. Nolan seal of approval. All right. Yep.
So is the point of this whole activity to cut down purely on code reuse plus get the extra speed? Because you could go with maybe an all-live approach that share templates and maybe Keo on the client side, and then you're using the same accessors to kind of walk and build up your template, but still produce the server-side rendering one way through a REST endpoint versus the app. So is this really just heavily code reuse you're trying to cut down on plus the speed, or?
Yeah, so the question was, basically, why am I doing this? Is this for code reuse and page load speed? Yeah, it was also kind of laziness. So if we go to, let's see if I can go back to Emacs. Oh yeah, it's right there. Derp. Where is that? That's in front. Okay, so this is the actual loading my homepage. So as you can see, I'm using Sublono, and oh, that was another thing I didn't talk about, was I actually ported Sublono as well. That was easy though, so I didn't. So the question was, why not use NLive or something like that and separate the templates out? And the answer was I didn't really want to, move all of the functions everywhere. So if you did that, you totally could do that, but you'd have to move all of your own functions into a separate thing and then use NLive, which I never quite understood. So it was just simpler to shadow ohm and not have to move anything else. So, yeah. Anything else? All right, great. Thanks.